first. For the first, then you can see the stem moving down. Yeah.
The stem here is represented by this broken line.
Yeah.
And
So
the broken line is negatively sloped everywhere. So the implication here is that the news is either moving or is produced at progressively low altitudes.
yeah, so I'm wondering, so are there any difference between the stem occurred for the first step or the stem occurred later?
Well, why those stems occur and how exactly and where is not very well understood. The very first space stem occurs in association with the initial corona. So
Yeah.
what you see here, the initial corona.
Yeah, that's right.
Somewhere inside this burst of streamers of the
Yeah.
corona, that space stem is born.
Yeah.
And here, as you can see, the broken line is broken. There is a gap.
Yeah.
And this is because in stream camera records, or image converter camera records, this streamer burst is very bright.
Yeah.
And it's very difficult to see what happens. And only after some time, you detect another space stem.
Yeah.
And those space stems, they can be multiple. Shown here, 3 kind of in parallel. In previous record, they're kind of in series. And both situations were observed.
Yeah, yeah, that's right. So the stem is moving or just staying there. Especially the initial seed is moving or
Yeah, it appears to be moving. That's
Yes,
right,
yeah.
because of this negative slope.
Yeah.
That's right. And this is kind of a static picture about this instant of time at this position. So it is moving, which means the positive streamers here, they become longer.
Yeah. Have you found evidence from your, high video recording? I know Dr. Biaggi will make a presentation at AGU. We show some fine picture from last step. So have you seen anything? I mean, the seed, the stem is moving or just stay there?
I don't think so. There is any experimental evidence for that yet. And in high-speed video camera records, this is a pretty good framing rate, 4 microseconds between rates. And it's still not fast enough to see the step formation process. It takes maybe a microsecond or less. Here, 4 microseconds. So each frame shown here probably includes multiple steps. So there's a cumulative effect of multiple steps, leave alone tracking motion of space step. No, we are not there yet. We need a better resolution. Maybe you can design an instrument that can do sub-microsecond. We need to go sub-microsecond in order to shed some light on this process.
Thank you very much.
Any other question? Thank you for your wonderful talk. You showed a method to infer the ionospheric height. You use a return stroke waveform. And use T1 and T2.
Right.
In a recent paper by Lei and Shaw, they use peaks, right? But I don't quite understand why you can use T1 and T2, because T1 seems to be not controlled by the atmosphere.
Yes, this is a very good question. We used T1 plus T2 because of the limitations of our database. This data set was acquired originally for a different purpose. We wanted just to characterize the distant electric field waveforms, and this issue of interaction with ionosphere occurred later. At that time, the database was already reduced so that it was not possible to find a time interval between the peaks. However, in collaboration with Steve Kammer of Duke University, we examined some of his records, magnetic field waveforms recorded at Duke University, and compared the time intervals between peaks and between zeros. Between zeros means from here to here, T1 plus T2, and between peaks means from one to this one. And the results are pretty consistent. So we feel kind of comfortable about this, but in the future, we need to repeat this and measure between peaks. I think it's a better measure. Although, for daytime ionosphere, because this reflection is so dispersed, there will be necessarily an error involved. It's like with the time of arrival method. Due to propagation effects, the front gets degraded, and when you measure the position of the peak, it's not the actual position of the peak. It's well distorted because of propagation effects. Here also, because of this low-pass filter behavior of daytime ionosphere, there will be an error into this. So it needs to be investigated. Maybe we should perform measurements under nighttime conditions. In that case, the cross skyway will be sharper and we will have some resemblance of this one. Then we can better identify the position of the peak. So this is just the beginning. However, I think this is sufficient to show the point that subsequent strokes get reflected at lower heights. I think this is pretty robust result that is also confirmed by data from magnetic fields.
Okay. The result shows that the ionosphere changes by 11 kilometers.
The difference here, 9 kilometers. Is it 11? Oh yeah, it is 11.
How do you think the errors in estimating the height?
The errors are indicated here. The standard error of mean value of H1 is less than 2% in each case.
Okay.
It is found as the standard deviation of the distribution of H1 divided by the square root of the sample size. The sample sizes are given here, just over 100 events in each case, and the standard errors in mean values are less than 2%. So it is, they do not overlap. So clearly, the confidence intervals do not overlap. Because confidence interval is for 95% confidence interval, you need to double this. So,
in this method, is it do you need to first determine the location of the return stroke?
Yeah, locations were obtained from an LDN data. So 255 kilometers in this particular case. So the distance.
So estimation of the location of return stroke also involves some errors. And I think that the errors may...
Yeah, no, very small. I wouldn't worry about this because, as I said, presently 300 meters. And if we measure 255 kilometers and we have 300-meter error, that's nothing.
Thank you. And I have another question about the CID. You showed the CID in two return strokes. And because they like the horizontal distance like 7 kilometers. So it seems that they are not in the same process. Actually, in my opinion, CIDs seem to be able to initiate lightning processes, but it seems that they cannot be. So far, there seems to not very strong evidence that CID can appear in between the discharge processes. How do you think?
Yeah, well, it is hard to tell. Certainly, the CID appeared within the range of distances that could be indicative of the same flash. Because when we talk about cloud-to-ground discharges, there is also in-cloud portion. And for multiple stroke flashes, the larger the stroke order, the longer the horizontal extent of the channel inside the cloud. So it could be easily 10 kilometers, could be even 15 or maybe more kilometers. So 7 kilometers horizontally does not mean that this is a totally independent discharge. This is not enough to say. There is a difference in height. Of course, the return strokes to ground, the radiation came from the bottom of the channel. And the channel extended to, well, in Florida, 7-8 kilometers approximately. For CID, this particular